Section 1.4 Polynomials. In this section we're going to talk about polynomials and some of the things we can do with polynomials. Anytime we learn something new in math, we always want to do the four basic operations: addition, subtraction, multiplication, and division. So we're going to do stuff like that. But before we can talk about polynomials, let's talk about something called algebraic expression. What's an algebraic expression? An algebraic expression is a mathematical expression that contains numbers, variables, and operations. Okay, so anytime you see something that contains numbers, variables, and operations, we call it an algebraic expression. Okay, so here are some examples of it. We have an expression here, mathematical expression that contains operations, variables, and numbers, so it's an algebraic expression. Here's another one that contains a radical, but it has numbers and variables. Okay, so those are examples of algebraic expression. What we want to do today is take a look at one specific algebraic expression called polynomials. Okay, so let's define a polynomial. So a polynomial is a algebraic expression of the form this, where you have some number times x to the n, a variable raised to n, plus another number times x to the n minus 1, plus, and so on. And then you have a2x squared plus a1x plus a0. Okay, so where a's, all these a terms that we are talking about here, okay, are just some real numbers, just any number that you can think of, and n is a natural number and can be 0. So n is a natural number, which basically, if you recall, when we talked about exponential numbers, we defined natural numbers are positive integers, not including 0. But n can be 0 in this case. So it's a natural number, or it can be 0. Okay, so let's take a look at some examples of polynomials. Okay, so the one I gave you earlier, 3x plus 2 is a polynomial. Out here n is 1. Okay, another example of a polynomial could be 4x cubed minus 3x squared plus 1. That's an example of a polynomial. Okay, so these are just examples of polynomial. The key requirement for something to be a polynomial is the exponent. This exponent can be 0 or has to be a positive whole number. That's the only requirement out here, x to the 0, so it's 0. So you can see that. So the only requirement for an algebraic expression to be a polynomial is the power that we are talking about here has to be a positive integer or 0. Okay. Oops, I shouldn't put and here, it should be or. Alright, now that we looked at some examples, and you can create all different types of examples. Out here, this is a polynomial that is of variable x, but you're not limited to that. I could create a polynomial like this. I could have 3x squared y cubed plus 5xy squared plus 6xy. That's a polynomial. Remember, the only requirement is the powers have to be positive integers, okay, or 0. So that's the only requirement. So those are polynomials. Okay, this is a polynomial, by the way, because the highest power is n here. As you go down, the powers keep decreasing. So the highest power is n, so we call that the degree of the polynomial. So we say that's the nth degree polynomial. Okay, and we'll define all of that in a second. Alright, so let me go ahead and introduce some terminology with that always goes hand in hand with polynomials. Okay, so let's talk about the first thing, the number of terms. Basically what that means is the terms are separated by addition or subtraction. Okay, so like for example, in this case, this polynomial has two terms because it's separated by addition or subtraction. So I have 1 and 2 terms. Okay, this polynomial has 3 terms: 1, 2, and 3. So terms are things that are separated by addition or subtraction. Okay, and the sign always goes with that term, just so you know. This also has 3 terms. Usually some polynomials, if you have one term, they have special names. They're called monomials. Okay. If they have 2 terms, they're called binomials. If a polynomial has 1 term, and if it has 3 terms, it's called a trinomial. And that's about it. After that, they stop naming them, but you know, you can identify them, okay, that way. So the next thing we want to define then, we want to talk about then, is the coefficients. Coefficients are the numbers in front of the variables. So for example, in this problem here, in this generic definition of a polynomial, okay, these would be the coefficients. All the a terms would be called the coefficients, because those are the numbers in front of the variables. Okay. So in these example that I have here, let's take a look at what my coefficients are. My coefficients in this example are 3 and 2. Out here they're 4, -3, and 1. Out here they're 3, 5, and 6. So those are my coefficients, just the numbers in front of the variables. Okay. The next thing is the degree of the polynomial. It is the highest power, and this could be the sum of the exponents in each term. Okay. So the degree is the highest power that's present in the polynomial, and if the polynomial is made up of more than one variable, then you look at the sum of the exponents in each term. So let me give you some example. Well, before I give you some examples, let's just talk about these ones. The highest power out here is 1, so the degree of this polynomial is 1. Out here the powers are 3, 2, and this is kind of like x to the 0, so the highest power is 3, so the degree is 3. Out here, since it's got two variables, when we look at the degree, we look at the highest power. When we try to find the highest power, we add the exponents in each term. So we get 2 plus 3 is 5 here. Out here is 1 plus 2 is 3, and 1 plus 1 is 2. So the highest power is 5, so the degree is 5. Okay, so the degree of the polynomial is the greatest degree that's present, or the greatest power that's present in the polynomial. And when you look at each term individually, and if there are 2 variables or more variables, you add those exponents to figure out the degree. Okay, so let's take a look at just a couple examples really quick. Okay, we'll just draw a table here. Oops. And sometimes there's other terminology that goes with it. So here are some expressions. I'll just call it E expressions. So I'll give you about 3 or 4 of them. So let's say if we have 3xy squared minus 8xy plus 2, or we could have minus 5x to the 5th plus 4x cubed minus 1x, or we could have x to the negative 1 plus 3x plus 2, or we could have 12x squared plus 6x to the half minus 1. We could have 2 more here. We could have 4x cubed plus 6 over x squared minus 2, and the last one is 13x squared plus the cube root of x minus 4x. So the first thing we want to do is decide which of these are polynomials. Okay, so I'll just put polynomials question mark. The next thing is, if they are polynomials, we want to identify the degree right away. Okay, then we want to identify the number of terms, because that's going to be important later, and that's why I'm introducing these terminologies. And then the last thing is we want to figure out the coefficients. And sometimes you can also have another thing that you need to know, something called the constant term. The constant term is a term that doesn't have a variable in it. Okay, so let's take a look at it. Now remember, the only requirement for an expression to be a polynomial is the powers have to be positive, integer, or zero. That means they cannot be fractions, they cannot be decimals, they cannot be negative. Okay, so if you look at the powers here, this is 1, 2, 1, 1, so they're all nice integers, so this is a polynomial. So let's find the degree. Since it's made up of two variables, in each term we add the powers to figure out the degree. So this is 1 plus 2 is 3, 1 plus 1 is 2, so the highest power is 3, so the degree is 3. The number of terms, I have 1, 2, and 3, so I have 3 terms. Okay, it seems like all of the expressions I picked had 3 terms, so let's make this something like that. Okay, the coefficients are the numbers in front of the variables. In this case they are 3, -8, and 2. And the constant term is a term that doesn't have a variable in it, which is 2. Okay, so we can go ahead and do the same thing. Look at the powers, they're all positive integers or 0, so we're good. So this is a polynomial. The next thing is the degree. The highest power in this case is 5 and 3 here, so the highest power is 5. The number of terms, there are 2 terms here. Okay, and if you notice, the coefficients are the numbers in the front of the variables, which is 5 and 4. And the constant term, there isn't any, so we'll put 0, because there's no term without the variable. Out here, since the power is negative, we know the powers have to be positive integers, so this is not a polynomial, so we don't need to worry about this at all. Okay, this one, the power is a half, which is again a fraction, so it's not a polynomial, so don't need to worry about that. Over here, this is in positive integer, but this is not written in the polynomial form. Remember, to write something as a polynomial, all the x's on the top, they're not on the bottom. So if I were to rewrite this expression just to show you with x on the top, it would look like this. Using the properties of exponentials, when you move something from the bottom to the top, what do we do? Change the sign. So we get this, and now we have a negative exponent, and we cannot have that for polynomials, so that doesn't work. Over here in this last example, this is positive, this looks like it's positive, but keep in mind here there's a radical. Another way to write a radical is what? If you recall, if you have the nth root of b, I can write it as what? B raised to 1 over, and we've talked about that when we did rational exponents and radicals. So technically this polynomial is, that algebraic expression is 13x squared plus x raised to 1/3 minus 4x. So we have a fraction, we cannot have that, so that's not a polynomial. So in this list, only 2 of them were polynomials, and we were able to identify some of the things that we talked about. Now that we know what a polynomial is, what can we do with it? Okay, so let's talk about that. So the first thing we can do is we can evaluate a polynomial. That means we can find the value. Evaluate basically means find the value. Okay, so let's take a look at it. A couple examples. This is fairly straightforward. Let's say that if I have something like this, if I have 6x cubed minus 5x squared plus 4x minus 3, and I tell you that evaluate the polynomial if x is equal to -2. Okay, That means I want to know what is the value of this polynomial if I were to replace all the x's with negative 2. Anytime you're working with a formula or something like this where you're evaluating, when you're plugging values for variables, always put parentheses if the number is negative. Even if they don't give you that, just go ahead and do that. It's really good habits to get into. So now I'm going to substitute this x into this expression and replace all the x's with parentheses negative 2. So I get 6 times parentheses negative 2 cubed minus 5 times parentheses negative 2 squared plus 4 times parentheses negative 2 minus 3. If you recall from your early days of arithmetic, we always follow order of operations when you have a lot of choices in terms of operations to perform. So we always do the exponents first. So let's do that. So negative 2 cubed, negative 2 times negative 2 times negative 2 is, we get negative 8, okay, minus 5 times negative 2 squared, negative 2 times negative 2 is positive 4, plus we get 4 times negative 2 minus 3. I took care of my exponents. Now we do multiplication from left to right, or addition or division. So in this case we don't have any division, so let's just do multiplication. 6 times negative 8 is negative 48, minus 20, minus 8, minus 3, and then it's just a matter of adding these numbers up. Okay. Now, thing I want to point out over here is if I didn't put these parentheses, then when I cube and stuff, I would have something like this. This would mean I'm just cubing the 2, or when I have the squared, would mean I'm just squaring the 2. But by putting the parentheses, we are saying that this is my base, that's what I want to cube. This is my base that I want to square. So it's important to always do that. If you have a negative number, put parentheses before you push that into the expression. Now it's just a matter of adding all of these, since it's negative 48 minus 20 is negative 68, minus 8 minus 3. Add these two. Negative 68 minus 8 is negative 76 minus 3, and you get negative 79. That is the value of that polynomial. So it's fairly straightforward. All you have to do is just please remember to put parentheses around those things when you're evaluating them. Okay. The next thing we want to talk about when we talk about polynomials is we want to talk about adding and subtracting polynomials. So in this case, what we do is we collect the like terms. Okay, that is terms that have the same variables and powers. Okay, so that's what we do. So let's take a look at some examples right away. So let's say if I have two polynomials, 3x cubed minus 12x squared plus 6x, and I'm going to subtract minus 2x cubed plus 4x squared minus 3x plus 2. So I'm going to take this polynomial and subtract this polynomial. Now before you do that, since we're subtracting and there's parentheses here and there's multiple terms there, we need to distribute that negative, or you can think of it as -1 that you're distributing. Okay, so first thing we'll do is get rid of the parentheses across the board. So let's do that. So we get -1 times -2 is positive 2x cubed minus 4x squared plus 3x minus 2. So we're taking -1 times -2 gives us 2, -1 times positive 4 gives us -4, and so on. Now we collect the terms that have the same variable and powers. This has x cubed, so I can collect those two. So what do I get when I add these two? I have 3x cubed plus 2x cubed, so you add the coefficients in the front. That's what we do. Okay, when I say collect, we add basically the coefficients in the front. So 3 plus 2 is, we get 5x cubed. Then I have -12x squared minus 4x squared. Okay, so we get -16x squared. And then we have 6x plus 3x, so that gives me 9x, and then we just have a negative 2. So there's your answer. Okay. Now, I do want to point out something just for future reference. There's actually middle steps that are happening in here that we don't write it, we just collect them without performing those middle steps. Like for example, how do I add 3x cubed minus plus 2x squared? We said that it is 5x squared, but how does that happen? Well, if you notice, both of these terms have something in common, which is x cubed. They both have x cubed in it. So I can take that x cubed out, and I'm left with what? 3 plus 2. So I took that x cubed out of here, so it's gone. I took that x cubed out of here, so it's gone. So I'm left with 3 plus 2. What is 3 plus 2? Which is 5. So I get 5x cubed. That's how I get those numbers. So that's how we actually add these things, these coefficients. Okay. So we collect the like terms. Okay. And I forgot to finish the line here, and add the coefficients. So when we collect the like terms, we basically add those coefficients is what we are doing. Okay. Just keep in mind when you're subtracting to distribute, that negative common mistake students make. They forget to do that, and obviously you're going to get the wrong answer then. The next thing we can do with a polynomial is we can multiply them. So let's talk about that. So multiplying polynomials, and that just boils down to basically distributing each term of the first polynomial into the entire second polynomial. So that's what it boils down to. So here are some examples of that. So let's start with this. Let's if you have 2x minus 3 times minus 4x squared plus 3x minus 2. So you can clearly see this is a polynomial, this is a polynomial. I'm multiplying them. So what do? I take each term of the first polynomial, so let's start with this one, and multiply it by each term of the second polynomial. We distribute it. Okay. So we distribute each term of the first polynomial into the entire second polynomial. So we take 2x times this, 2x times this, 2x times that. So let's do that. So let's just show you what's happening on the side here. 2x times, so I'm going to take 2x and multiply it by negative 4x squared. If you remember when we did the section on exponential numbers, that's what we're doing really. Let's take care of the 2 and the negative 4, so we get negative 8. Then you have x multiplied by x squared. Anytime you multiply two exponential numbers with the same base, you add the exponent, so we get x cubed. So in this case we get negative 8x cubed plus 6x squared, because 2 times 3 is 6 and x times x is x squared, minus 4x. Negative 2 times 2 is negative 4x. Now we do the same thing, except this time we distribute negative 3 here into the second polynomial. So we get positive 12x squared minus 9x plus 6. Negative 3 times negative 4 is positive 12. Negative 3 times positive 3 is negative 9. Negative 3 times negative 2 is positive 6. Now that we are done distributing and getting rid of our parentheses, we collect the terms like we did before. And by that I mean is we add the coefficients of the like terms that have the same variable and power. So this term is the only one that has a cube in it, so I can't add anything to that. But this one has a square, this one has a square, so I can add those coefficients in the front. So 6 plus 12 is 18x squared. This one has an x in it, this one has an x in it, just x to the 1 in both cases. Negative 4 plus negative 9 is negative 13x. And then we have a singleton 6. So that's how you multiply polynomials. You just basically distribute each term of the first polynomial into the entire second polynomial. Sometimes we can speed this process up. For example, if I give you something like this, 5 minus 6x times 5 plus 6x, I can do it the way I just showed you. I can take this 5, take each term of the first polynomial, multiply it, take the 6, do the same thing. And that would work perfectly fine. But you should recognize this. We've talked about these. These are conjugates. Isn't that right? I'm taking this polynomial, multiplying it by this. They're exactly identical except for the sign in the middle. Whenever that happens, we call these conjugates of each other. And if you recall from the previous section on radicals, anytime you multiply two conjugates, okay, all you have to do is square the first number. So what is 5 times 5? Get 25, and put a minus sign and square the second number. What is 6x times 6x? So you have 6x times 6x. You get 6 times 6 is 36. X times x is x squared. And you can see how easy that is to do if you recognize that these are conjugates. Okay, so please remember that. Here's another example of that. Let's say if you have x squared minus 3 and you have x squared plus 3. Again, I have two polynomials I'm multiplying. They're exactly identical. So the only thing that's different about them is the sign in the middle. So I can speed this process up of multiplying by just taking the square of the first x. What is the square of x squared squared? Because you want to square that first term. Anytime you have two exponents next to each other, we multiply, so we get x to the fourth. So we get x to the fourth, put a minus in the middle, and you square the second term. What is 3 times 3? 9. You're done. Okay, so always look for that. Conjugates are very, very important. Okay, and they come from some, they actually result from a formula. So let me talk about that next. So let's talk about some formulas. Always memorize formulas. It's very vital that you do that. Okay, the three formulas that you should always, there's 6 total, but for now we'll just talk about the 3 here. If you're multiplying a minus b and a plus b, if you're multiplying two polynomials or two expressions that are exactly the same except for the sign in the middle, we call them conjugates. And then when we multiply them, we just get the square of the first minus the square of the second. All you do is square the first number, put a minus sign, square the second number, and you're done. So this formula we've already been using in the previous section, and I just showed you some examples. So this is the first formula you need to know. This formula has a name. It's called difference. Actually, I won't give you the name right now. I'll give it to you in the next section when we do factoring, so it'll be easier. The second formula is this one. If you have a plus b, the whole squared. Now I do want to point one thing out. This is not equal to a squared plus b squared. Remember, when we have something like this, a plus b squared, we kind of distribute sort of, so we get a squared plus b squared. That's correct because of the multiplication. But when you have addition, you cannot do that. That only applies to multiplication. So please do not abuse that. Okay, so this is not equal to that. So what is the formula for a plus b squared? Well, square means what? You take the base, which happens to be this, and multiply by itself twice. So I take the base and multiply by itself twice. And then these are not difference of two, these are not conjugates, so I actually have to go ahead and distribute and do them. So I get a times a is a squared, plus a times b is ab, plus b times a is ab, plus b times b is b squared. So I end up with a squared plus, I have ab here, so I can add them up. I get 2ab because each has a 1 in the front, plus b squared. So that is the formula for a plus b, the whole squared. Okay, so a couple things to note over here. This is something students tend to do a lot. They'll see something like this and they'll just take the square of the first and the square of the second. That's not true. And you can see that if I were to actually multiply this out, I just don't get the square of the first and the square of the second. I still get this term in the middle also, which is 2 times the first and the second term here. So it's very important that you realize that. We call these all formulas have names, but I usually tend to not give them. But this formula, for example, is called difference of two squares because there's a minus sign here and there's a two squares here. This is called a binomial square because there's two terms here, binomial squared. So these all have names, but if you just look at the formula and note that if you memorize the formula, you can just use it. For example, if you have a binomial squared, if you have two terms added together squared, you'd square the first, square the second, and in the middle you throw in 2 times the product of the first and the second term. Okay, so I'll give you some examples of that. There's a variation of this formula that I just gave you. Instead of a plus in the middle, if you had a minus in the middle, then you get a squared plus b squared and then minus 2ab. So in the middle you end up with that. So those are the 3 formulas you should know, and I really would encourage you to memorize them. They're very useful. Okay, it'll speed that up. So let's take a look at a couple examples that utilize these. I already gave you examples of the first formula, the conjugates. There's 2 examples right there. Okay, but let me give you one more just to get the appetite started. So let's say if we have x squared minus 2y and I have x squared plus 2y. I'm multiplying 2 polynomials. They have 2 terms. They're exactly identical except for the sign in the middle. So that tells me that these are conjugates. So to find the product of this, all I have to do is square the first. So what is x squared squared? It will be x to the 4th. So we get x to the 4th. Put a minus in the middle and square the second. What is 2y squared? So you get 4. 2 squared is 4 and y squared is just y squared. Please remember, I can distribute here sort of, and again I keep using the word distribute. That's not mathematically right, but it's easier for students to understand that. But I cannot do that when there's a plus sign in the middle or a minus sign in the middle. It only works when you have multiplication. So this gives me 4y squared. So there's the answer for that. Let's take a look at the other 2 formulas. Let's say if I give you this, if I give you 2x plus 3 the whole squared. This is a binomial because it's got 2 terms, and so I'm taking the square of a binomial. So one way to do this is just to show you, because this is my base here, I can take my base and multiply by itself twice. And then I can distribute this, and I can do that. That'll work out fine. But it's always nice to know the formulas. It speeds things up. So according to the formula that I just gave you right out here, I have a binomial with a plus sign in the middle squared, which is what I have here. Okay, what do? I square the first number, a. I take the square of the first thing, a. Out here, a is 2x, so I square 2x. What is 2x times 2x? It is 4x squared. Then I have plus 2 times the first and the second number. This is my first and the second number, so let's multiply those first. 2x times 3 is 6x, and then you multiply that by 2. So 6x times 2 is 12x. Plus, I get b squared. b is my second term of the binomial. So I square 3. 3 times 3 is 9. There's your answer. So if you have this formula memorized, it really does go extremely fast. Okay, let me just do 2 more examples of that. Let's say if I have 4x minus 11y squared. Okay, again, take a look at it and see what you're doing. This is a binomial since it has 2 terms, and you're squaring it with a minus in the middle this time. So according to our formula, what do? It's right up here. Okay, we start by squaring the first term of the binomial. This is my first term. We square that. So what is 4x squared? What is 4x times 4x? It's 16x squared. Then we take 2 times the product of the first and the second term, and then throw in a negative in the front. So let's do that. So what's the product of these two terms? What is 4 times 11 is 44xy. That's what we get. We get 44xy, and then we multiply that by negative 2, right? Because there's a negative 2 in the front. So you get negative 88xy, and then we take the square of the second term. What is the square of 11y? 11y times 11y is what? 121y squared, because that's what 11 times 11 is. Okay? So there's the answer to that problem. It's the last example of this. And the more you work through, the more examples you work through, the better, easier it'll get. Okay? So let's just do this one. Let's say if you have 5x squared minus 6 the whole squared. Again, it's a binomial. It's got two terms, and I'm squaring it with a negative in the middle. So what do? We start by taking the square of the first term, so square of this. So let's do that on the side here. I have 5x squared the whole squared. I want to square that. So 5 squared is 25. X squared squared, you multiply those, so you get x to the 4th. So we get 25x to the 4th. Then in the middle you get negative 2 times AB. So let's multiply AB. AB is a product of the first and the second term of the binomial. So let's multiply these two. So we get what? I'll just do the work on the side so you guys can see that. So 5x squared times 6 is 30x squared. And then you multiply this by negative 2, because that's what I have in the front. So I get minus 60x squared. And then we take the square of the second term. What's the square of 6? 6 times 6 is 36. And again, I'm explaining this to you, so it takes a few minutes to do, but if you know these things, it goes really fast. Like for example, if I have x cubed minus 2y squared, let's put a plus here. So I'm doing a binomial. It's got two terms squared. Well, I can do this on the fly very quick. I get x cubed squared is x to the 6. Then I multiply those two, so I get plus 4x cubed y squared, and then I square the second term, so I get 4y to the 4th, and I'm done. Because I squared this to get this, I squared this to get this, I multiplied these two, and then I multiplied that by 2 to get the middle term. So you can see it goes very fast. So that's an introduction to polynomials. We want to work with polynomials a lot in this class, so you really need to get very fluid with them. The main topic about on polynomials is actually going to be covered in the next section, which is factoring polynomials. That's going to be very, 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 very important for this class. You absolutely have to master factoring if you want to succeed in college algebra. So that's what we are going to do in the next section. So for now, practice the homework problems to get good at this, and when you're done with it, you can move on to the next section.